In Chapter 4, we are beginning to take a look at the way psychoactive substances impact the brain. This is where we start to understand that addiction is much, much more than an issue of willpower, and we find out exactly what happens when substances are used. For this chapter, we are going to first take a look at the major components of the nervous system and then move to more specific elements such as neurotransmitters. To start, we're going to first focus on the concept of homeostasis. This basically looks at the body's desire to maintain balance at all times, or really to maintain a status of equilibrium. Humans must maintain their environment within certain limits, and some examples of the areas we do this are temperature, acidity, water and sodium content, and glucose concentrations. It's important to note that psychoactive drugs impact homeostasis. We see that psychoactive drugs impact homeostasis in a variety of ways, and in particular, there are impacts on all three of the nervous systems, the somatic, autonomic, and central nervous system. Breaking these down, looking first at the somatic, this is the part of our body that interacts with the environment and is involved with processing sensory information. This is the system that manages our voluntary actions. The autonomic complements the somatic by functioning more below the level of consciousness and managing our involuntary actions. It encompasses things like our heart rate, digestion, and respiration. This system is generally divided into two main branches: the sympathetic, which is responsible for effects such as increasing our heart rate, increasing our breathing rate as needed. This is the branch that creates what we refer to as a fight, flight, or freeze response when faced with a sense of danger. The parasympathetic is what we refer to as the rest and digest system, and will do things like slow our heart rate and slow our breathing rate as needed. Lastly, the central nervous system, which includes the brain and spinal cord, and this is the area responsible for a range of activities including cognition, memory, mood, and coordination. Taking a closer look at the specific areas of the brain impacted by addiction, the three major structures most impacted are the cerebral cortex, the limbic system, and the brainstem. The cerebral cortex, often considered to be gray matter, is responsible for maintaining our cognitive functioning. It is divided into four main lobes. First, the parietal, which is as a whole is where our sensory import is processed for things like movement, orientation of the body, and touch. Next, the frontal lobe is involved with impulse control, planning, and decision making. The temporal lobe focuses on auditory perceptions and language. And lastly, the occipital, which is most known as the visual processing center. With psychoactive substances, we often look at how substances can hijack the brain, meaning the processing that takes place is compromised. So, for example, substance use can impact the parietal lobe and it can be compromised by having a slower reaction time, slower movement, and orientation. The frontal lobe, substances can interfere then with solid decision making and can result in a loss of reason, lack of inhibitions, and no self-restraint. With the temporal lobe, an interference can result in things like slurred speech, and with the occipital, it can result in blurred vision. This alone may not seem like such a concern. However, when that is matched with the impact on the limbic system, we really begin to see some concerns. To illustrate what happens when the cerebral cortex and the limbic system are both compromised, think of this scenario. Have you ever been at a crosswalk where the lights weren't working properly, where you might see a misworking of the stop and go lights? Well, this is what occurs within both the cerebral cortex and the limbic system. The brain is experiencing a type of breakdown of its stop and go system. How this happens is with the overload on the limbic system by substance use. If the cerebral cortex is considered the area for cognitive functioning, the limbic system is most known for being the emotional brain, or what we refer to as our old brain, where our drives, formation of emotional memories, and triggers for pleasure are stored. Within the limbic system is the nucleus accumbens, or also what we call the reward pathway or dopamine reward center. Without psychoactive substances, when we do something enjoyable, this is the part of our brain that signals reward by releasing certain chemicals, which then increase our sense of pleasure and the desire to say to ourselves, hey, let's do that again. All substances, as well as certain behavioral addictions, to some degree push out dopamine, which generally results in a desire to do that action or use again and again and again. Even when with chronic use consequences develop, the desire to release the reward system often prevails over our stop system in the cerebral cortex. So in essence, psychoactive substances push the limbic system in override and take away the brakes of our cognitive functioning. Lastly, psychoactive substances also have the capacity of impacting the brainstem, which is an extension of the spinal cord. This is a small but very, very mighty aspect which controls things like functioning related to breathing, alertness, and our gag reflex. In addition, all information from the body to major parts of the brain goes through the brainstem. So basically, the brainstem has the task of informing the brain of what is going on in the body and vice versa. And this task can be negatively impacted when substances are used.